Hello all, this is Liji and today we will cover memory management in Python, variable scope and its lifetime. So memory management we will be discussing with reference to CPython, that is Python written using C language. Other kinds of Python will be having a different memory management altogether, so we won't be looking into detail into that. In case of Python, everything is an object. So whatever variable you create, integer, string, float, whatever you create, those are basically objects to the int class, float class, string class, etc. So if you see over here, what we are doing is we are creating a variable and we are assigning a value of 200 to it. Okay, so what internally happens over here is it creates an integer object in heap memory. Okay, it assigns the value 200 to it and it creates a x variable x in stack, and this x points to this integer object in heap. So that is what happens internally when you create a variable and assigns a value to it. So if you see over here the id of x, we are getting this much. Okay, so what is id is basically a unique identifier to a variable, and in case of CPython it returns as the memory location. So when we are creating this, when we created this integer object, now it the address in which it is created is this. Okay, so here for reference I have just mentioned as 1000, but actually this is the memory address in which this x is created. Now let us create another variable over here, that is y equal to 250. So what happens here again is it creates another integer object in heap. It assigns the value 250 to it, and the y reference variable y is created in stack, and this y points to this integer object. So if you see the memory address of y is this and memory address of x is this. Okay, so you notice that both are different. This is 84567 and this is 8455184. Okay, now here what we are doing, we are assigning x to z. Okay, so what happens is z Python knows that x is already there. Okay, and this x we are assigning to another variable, say z, and let us see what happens. So id of z is this. So if you notice, it's same as the id of x. So what internally happens is, since Python knows that we are reusing an integer object that is already over there, it doesn't create a new integer object in heap. Okay, it doesn't allocate a new memory location for that. Instead, it creates a variable z in stack and make it point to the existing integer object over in heap. So here both x and y, both x and z points to this memory location, and y points to a different memory location because it is having a different value. Okay, so same thing is highlighted over here. So if you see over here, x is z is a operator which checks whether both are referring to the same value. Okay, so we get true. X is y. When we check it, we get it as false because we know that y is created at a different memory location. Now if you see over here, m equal to 300. So whenever we create a new variable with a value, we know that it creates a new reference over there, right? It creates a allocates a new memory location in heap, and that memory location is assigned to the variable. So what happens is it creates a new integer object at this location, and then m is pointing to this location. Okay, now again if you see over here, n is assigned 300 and we are checking its id. So you can see that a new location is created, a new location is created where the value 300 is added, and that reference is assigned to n. So even though m and n are having same values, separate memory location is created and that references are given to these variables. Okay, so here you can see that the memory location is different. So when we check m is n, We get it as false because both are referring to different memory location. But when we check m equals to n, we get it as true because both are having the same values. So double equal to check compares two variables and check if the values are same. Then it returns as true or false. Is operator or not is operator checks whether both the variables are referring to the same memory location, and if it is referring to the same memory location, it returns as true, otherwise it returns as false. Now, Python does many techniques for doing memory optimization. Okay, so if you see over here, I am assigning m equal to 20, and this is the address in which it is created. Okay, and here again I am assigning n equal to 20, and this is the location in which it is created. If you notice, both m and n is having same memory location. But over here we saw that even though m and n is having different value, it is created in different memory location. Got it? But here when we created, both m and n is having same memory location. Why is it so? What happens is, when a program is created, Python script is created, what Python does, it automatically creates some memory location, some integer objects in memory from the values -5 to 256. So this for small integer values, it already keeps some memory location integer objects in memory. So it will be having some location where 1 is created, it will be having some location where 2 is created, it will be having some location where 20 is created. So till -5 to 256, it will be already having some memory location already allocated exclusively for that value. So when we are telling m is equal to 20, what it does, it doesn't create a new memory location. It just make m refer to this memory location already created. Similarly, when n is created, it just refers to this memory location. Okay, that is why both m and n are having same IDs over here. So this is done for integers between -5 to 256 only. Okay, so if the value of an integer is greater than that, it will create a fresh memory location, create a fresh integer object. So this is an optimization technique from Python by which we can reuse the existing memory location that is already allocated. Okay, so that is why here the memory location for m and n is same, while here on top, when we assigned m and n as 300, we got different memory location. Okay, now let us see. We are creating a string 1, str1, and we are assigning Python to it. ID is this. We are creating str2 and assigning Python to it. ID is this. Here we can see that again, both the strings are having same memory location. Okay, so what happens is, Python creates a string over here, Python. Okay, and it assigns, it makes str1 point to it. Okay, later it found that yes, we are creating another variable str2 with the same value. So what it does, it doesn't recreate a new memory new memory location. It doesn't allocate a new memory location. What it does, it makes str2 also point to this memory location. Okay, that is why both of them are having same IDs. Okay, now if you see this same thing over here, I'm having str1 equal to I love Python. Okay, so what happens is, earlier we had a memory location over there. Okay, see here, earlier we had a memory location over there and it was having Python in it. Then here again I reassign some value to it. Okay, so what it does, it creates a different memory location and it adds a value I love Python, and that reference is given to str1. So str1, instead of point to Python now, it will point to I love Python now. Okay, and if you check str2, I am again assigning I love Python. ID is different. This str1 is ID is different, str2 ID is different. Okay, so what Python does is for small strings, it checks if a same string is already created. If the same string is already created, it doesn't allocate a new memory location. It just gives that reference to the new variable. But in case of bigger strings, what it does is it always creates a new memory location, allocates a new memory location, and it gives reference to that variable. That is why for Python, both str1 and str2 were pointing to the same memory location, but in case of IloPython, str1 and str2 is pointing to different memory location. So these are few memory optimization techniques from Python, basic memory optimization techniques from Python. Now let us see how garbage collection works. First, let us understand what is garbage collection. Okay, so here we have x, which is having the value 200, z, which is assigned z equal to x we did. So z is also pointing to 200. Okay, so this memory location, that is 1000, and y is pointing to another memory location which is having the value 250. Okay, so here id of y is this thing. Okay, now what I am doing here is I am reassigning y with another value. Hello I am assigning. So what happens is, as we have seen earlier, Python allocates a memory for hello, and that reference will be given to y. So here if you see, the id of y got changed. Here this was the id for y earlier. Y was pointing to this memory location. Now y is pointing to this memory location. Okay, so what exactly happens internally is, initially y was pointing to this area. Okay, y was pointing to this area, but later when the assignment happened, y pointed to this area. Okay, this location. Now there is no reference to this location. Okay, so when there is no reference to a location, it has to be freed, right? So the process of freeing of location which doesn't have any reference to it is known as garbage collection. In case of Python does this garbage collection by itself. What it does, it keeps tracks of number of references and removes an object when the reference count becomes 0. So here this location was having, initially was having a reference count of 1. This location is having a reference count of 2, and when this y got reassigned to hello, what happened is this reference count became 0, and this location is having a reference count 1 now. So Python found that yes, this location is having a reference count 0, so I can free this location. Now this location will be free and it is available to reuse. Okay, so this value 250 is entirely lost. So this is how garbage collection happens in case of Python. So today we saw, in case of memory management, we saw that how a variable is created in memory. Okay, so everything is an object. So memory is allocated in heap for the object, and its reference is given to a variable which is created in stack. Then when when a different variable is created, a different memory is allocated. But if we assign a variable with another variable, then it refers to the same memory location. And in case of Python, it does memory optimization for small integers, that is ranging from -5 to 256. It automatically creates allocates some integer object memory location, and when a variable is created with that value, it reference to this already created integer locations. In case of higher values, where above 256, this doesn't happen. So whenever a variable is created, it is having a new, it will be referring to a new memory location. In case of small strings also, Python tries to do this optimization techniques. It keeps track of the small strings created, and always whenever a new variable is created with the same string, then it makes it to refer to the old location. In case of bigger strings, always a new memory location is created. Python does garbage collection by keeping track of the references, number of references to a variable, and when the number of reference becomes 0, it frees that location automatically. So the programmers doesn't have to bother how how the garbage collection will be done. Okay, now let us see variable scopes. Okay, so when you are writing a program, not all variables are accessible from all parts of the program. Okay, and not all variable exists for the entire amount of time. Okay, so this availability of a variable in a region is defined by its scope. So when we say a region, like it can be the availability of a variable inside a function, it can be outside a function, it can be inside a block, and all those things. Okay, the lifetime of a variable is the time during which the variable stays in memory and is therefore accessible during the program execution. It will be more clear when we discuss these things. So global scope, when a variable is defined in the main body, okay, in the main file, it is known as a global variable. Okay, and it is visible throughout the file. Also, when the file is imported, that variable will be visible. So here we are having a variable x equal to 20. So when we print x, it is accessible to us. Okay, now again we are reassigning x to 50. I am defining a function over here. Then I am having another variable y equal to 30. So since this is the main program itself, both x and y are global variables. Okay, so when I call the function my function, it prints x and y. So value of x is 50 and value of y is 30. Here x value of 50 overrides the existing value of 20. But this x and y, even though they are defined outside the function, they are available in the main script throughout the script, and that's why it is able to access x and y. Hence that's why x and y are known as global variables. Okay. Now let us see what are local variables. Local variables are variables that are defined inside the function. So if you see over here, we are having another function. I am creating a new variable over here which is having the value 500. Now I am printing it. I'm calling the function, I'm printing it, I get the value 500. Now I'm trying to print the variable again, it throws an error. That is because this num variable, okay, this num variable is available only inside this function because it is created inside the function. Okay, so that is why it is available inside, only inside this function, and that is why when we try to print it over here, we get an error. Okay, so this variable, the scope of this variable is not, the variable is known as local variable, and the scope is local scope, and the lifetime of this variable is when I call the function, this variable gets created in memory. Okay, so when I call this function, what happens? The variable gets created in memory with the value 500. Okay, but when we exit from this function, the variable gets deleted. Okay, so the lifetime of that variable is the execution time of that function. That's it. Okay, so now consider this function. Here we are passing two parameters to the function a and b. So these parameters, function parameters, are also considered as local variables. So I am running this code. So I am calling the function with arguments 40 and 400 and 500. So a gets the value 400, 400, and b gets the value 500. Those are printed, and the id of a is printed. Okay. Now but when we try to print a outside the function, it throws an error because it is not defined outside the function. These are also local variables. The function parameters are also local variables. Now if I try to print the id of a, it says it doesn't exit itself. Okay. Now, how, suppose this, I am having a function over here and it is printing x. Yes, as we have seen, x is a global variable which we defined earlier. Okay, so when I am printing x, I get the value 50. Okay, now when so x is accessible inside the function, right? So when I here there is another function where I am making x as 100, then I am printing x. Okay, let us see what happens. Yes, we get the value as 100. Okay, but when I'm printing x over here, it is 50 again. So what happened here? Okay, so what happened is we are having a global variable x. Okay, this is a global variable. This is a global variable. Okay, so this global variable is available inside the function. Okay, inside the function, if function 3, this global variable is already available, that is x. But when we assign h equal to 100 inside the function, what it thinks as, it thinks that h is a local variable. So what it does is it hides this global variable, it creates another memory location that is with the value 100, and it assigns h is referring to that 100. Okay, so this is local variable h. So when the variable with the same name as global variable is created inside the function, this global variable gets hidden and this h points to this local variable. Okay, so when we print the value of h over here, it printed 100. But when we came out of the 100 and when we printed h, then it started referring to the earlier h, that is the global h, and that's why we got 50. So inside the function only this local variable exists, right? When we came out of the function, what happened is it is again referring to the global variable h. So that's why we got the value as 50. Now suppose if we want to change the value of this global variable inside the function, what we have to do is we have to mention that I'll be using global h only. I'm not creating any local h. Okay. So when I'm printing it, I get the value 100. And when I'm referring outside the function also, I am getting the value 100. Okay. So whenever you want to access a variable inside a function, the global variable inside a function, yes, you can print it, you can use it, you can do all the things there. But if a time comes you want to change that variable inside the function, then you have to mention that you are changing the global variable that function. Otherwise it thinks that you are going to create a local variable, because every new assignment creates a new variable, right? So you have to explicitly mention that no, I am referring to the global h, I am going to change that. So that's why we had to mention global h over here. Okay, to change the global variable. But if you want to create a local variable, you are free to do that without changing it. So then this will be a local variable and the other one will be a global variable. Okay, so there are mainly two scopes in Python. It is global scope and the local scope. Global scope variables are those variables that are available outside all functions, and it is applicable to all the functions, available to all the functions. Local variables are those variables which are available inside the function only. Its lifetime will be inside till the function executes, and its scope will remain to that function itself. We can access a global variable inside a function all the time. We can print it, we can use it. But if we want to change a global variable inside a function, we have to explicitly mention that we are referring to the global variable using the keyword global. That's all for now. Keep waiting for the next video. Thank you.